instantaneous rate of change. And what you're doing is there's two different types of change: average rate of change, which is f of b minus f of a over b minus a, and this is always over an interval. And if we looked at this type of an equation, this is y2, this is analogous, which just means it's kind of sort of like y2 minus y1 over x2 minus x1, which is what? That's slope. Now, instantaneous rate of change is always at a point. Now, how do we calculate the slope at a point? I was going to say dirigible for some reason. The derivative evaluated at that point, which is the tangent of the slope of the tangent line. So the first thing we got to do is f prime of x. So what do we get here? 10x plus 2. The second thing is just f prime at negative 3, which will give us our slope of the tangent line at negative 3, which would be 10 times negative 3 plus 2, which is negative 30 plus 2, which is negative 28. There's your instantaneous rate of change. It's a negative 28. Yeah, that's it. No, it's not horrible. And you just have to know the difference between average rate of change, which that's taken over a long period of time. Think of it like that. Average rate of change is over a long period of time, so the only way we can ever talk about a long period of time is through an interval. So we have to worry about the endpoints. We care about how it starts and how it finishes, and we get a nice average in the middle of it. Instantaneous means I need it at a point. And the only way we do that is through the derivative itself. Yes? Sure. Maybe. But probably not. Alright, let's say f of x is equal to, I'll do a nice, just easy one for you. I'm going to show you how to do it, and then if you understand how to do it, then maybe we can go a little bit more difficult. But once you see it, I think you'll be like, piece of cake. So this one, let's do intervals. Where f of x is increasing or decreasing. Alright, so this is essentially a first derivative test problem. So we get f prime of x, which is what? 3x squared, correct? Alright, so for the first derivative I need, well, one, we find f prime of x. Step two, what do? Set it equal to 0. And then solve for x. So we'll get 3x squared is equal to 0, so what's my x value? What's the only thing it can be? 0. Alright, step 3. Perform a sign test on f prime of x at your critical numbers. So we're going to do this. And we are going to be working on f of x is, or f prime of x. Now, pick a test point, -1, and I'll take +1, because those are easy points to deal with. So f prime at -1 is going to be 3 times -1 squared, which is 3, which is positive. So I know it's positive here. So if it's a positive value here, what does this tell me about f of x? Yes. The first derivative test, the sign test, is going to tell us that it's increasing on this interval. So I can say that it's increasing, so f of x is increasing on -infinity to 0. Now, take a look at the next one. F prime at 1, we get 3 times 1 quantity squared, and that ended up being the 3, which is positive there. Now, what does it tell me it's doing from 0 to infinity? It's still increasing there. So there's no interval where it's decreasing. And the original was a cubic function, which does this anyway, right? So it's increasing on the entire domain. Now, just if it was a negative there, we'd create our intervals based off of there. So, like if f prime of x was equal to like x plus 2 times x minus 1, you get your -2 and your 1, and we take a test value of -3, 0, 2. Now, 0 would give me a positive and a negative. So positive times negative would be what? Negative. So what does this tell me about the original function? Yeah. F is decreasing there. You put it in -3, you get negative times negative, which is positive. You put in a 2, that's 4, and that's a 1, so that's positive as well. So here we would say that f of x is increasing. I just made that one up, because the other one was it was pretty straightforward, just to show you what you kind of have to do. But if you get a more complex type of situation here, so we're going -infinity to -2, and then we're going from 1 to positive infinity. Remember, they're all open intervals. It's decreasing on -2 to 1. So the question is going to be very similar to the question that you had at the top. I'm going to give you a function. Basically, you take the derivative of it, find the critical numbers, do your tests, figure out. Remember, the first part of this sign test says, since our test value is positive, it's increasing. Since the test value is negative, it's decreasing. Since it's positive, it's increasing. That's what, if you want, when we get towards the AP exam, that's what you got to say. The sign test isn't enough. Even though everyone knows what it is, they want you to be a little bit more formal with your, like if it's a free response question, all you have to do is say, since it's positive on this interval, f of x is increasing. So instead of things that we know happen, we just have to write them down. Remember, the AP exam's more formal than what the midterm exam is going to be. At least because, one, the midterm exam is all multiple choice, and the other one is free response. But I will train you over the next 4 months how to answer the free response questions the right way. Stretch. Yeah, maximize or minimize, which is just first derivative test type stuff. Now, ladies and gentlemen, remember, optimization problems. Optimization problems are just problems where you have a function and you're trying to find extrema. You're trying to find a maximum value or a minimum value. So don't go crazy about what's happening in the problem, because it could tell you this crazy stuff about bridges or things like that, making a pile of stuff, or how much you got to sell, that type of thing. Just be sure that when push comes to shove, all you have to do for an optimization problem is the first derivative test. And if it's asking for a minimum, which one would be the minimum here? If it goes from positive to negative, is that a minimum or a maximum?
That'd be max.
Yeah, that's a max because it's going from a positive to a negative. It's increasing and decreasing, so it's a maximum. The roller coaster principle comes into play with that. This is the negative to the positive, or decreasing to increasing. There's your minimum. So if the question asks for a minimum, the way we find a minimum is take the derivative, set it equal to 0, find all your critical numbers, and then do your first derivative test to it. That's optimization, but that's also extrema. That's also, that's finding minimums, maximums, increasing, decreasing. All that stuff kind of goes right together. So don't get freaked out over that. Now there is one problem that you might get freaked out over. I have an answer. They are the extrema. Remember, extreme values, a maximum is an extreme value. What's the name of the test? First derivative. We're analyzing the function using the first derivative. So we just need the function to find the first derivative. Once we find the first derivative, everything we do in the first derivative test gets done to the first derivative. That would be if I needed to find the coordinates of like if I needed to find the coordinates of the maximum, I know x is equal to -2, but then I'd have to get f of -2. You would go back to the original because it's on the, remember, the maximum is on the original. This is just analyzing what's going on with the original function. If you plug it back into the derivative, you're not going to get anything out of that. If we're finding the entire coordinate of it, you got to go back to the original. Now, there's one question that I want to make sure that you guys, you might recognize this one. Well, that's because it's magic. The price of a CD, well, Blu-ray, since CDs pretty much don't exist that much anymore, is P of X. Same problem? Oh. So you get P of X cents. X is in thousands. Now, let's say that in a certain city, P of X was equal to 25 minus X over 10. And it says, how many Blu-rays need to be sold? Yeah, to maximize revenue. Now, the problem is they don't give you a revenue equation, do they? R of X, if that's equal to revenue, R prime of X is equal to P of X. which is your price equation. Now, remember, revenue is how much money you make, right? So the derivative is going to take it one step down and talk about how much you're charging in order to make your revenue. So if you want to think of a function like a revenue function, if you're accumulating money, the derivative, the first derivative of it is going to be the rate at which you accumulate the money. That has to be your price. So think of it like that. A revenue is accumulating money, correct? That word accumulating, you're going to start seeing it a lot once we get back. Because when we talk about integration, we're talking about accumulating things, amongst other stuff. So now, if I want to maximize this, knowing that this is actually r prime of x, set it equal to 0. Subtract 25 is equal to negative x over 10. Then what do? Multiply by negative 10. So that would be 250. So why'd I put it in thousands? Yes. So remember, if it's in thousands, a nice thing like this, for your test, yes, you can just say, all right, P of x is, all I have to do is set it equal to 0, solve for x, and be done with it. But I want you to understand that it's the derivative of the revenue. Price and revenue go together hand in hand. Just like position and velocity. Velocity is how you get to where your position is. Your price is how you get to what your revenue is. I want you to try to start thinking of functions in terms of that. It's all great and hunky-dory about what finding a derivative, but it doesn't mean anything at all if it has no basis in reality. And your derivative is a rate. It's always going to be a rate of what you're trying to find in the original function. If it's a revenue, price is what's going to give you revenue. If it's position, velocity is what's going to happen. Because that's what we measure that's what we need to know in order to figure out what our new position is. We need to know how fast we're going. So stuff like that. Multiply both sides by 10 is just 250. But the problem says it's in thousands. Now, unfortunately, it might also just say something like this. Which answer would be right? First one or the second one? Yeah, so make sure that you pick the right one. It's just not going to be 250, because then they say, oh, just sell 250 of them and you're good to go. It's not how mass market products work.